Today's problem 7.37. Given there is an element in plane stress subjected to stresses sigma x minus 11,000 psi, sigma y minus 3,000 psi, tau xy minus 4200 psi. So we have to determine the maximum shear stress and associated normal stress. So now we have to find first of all theta. So tan 2 theta p is equal to 2 into minus 4200 by minus 11,000 plus 3,000, so 1.01. So solving for the angles, we get following two sets. 2 theta p either is equal to 46.40 degree, giving theta p 23.20 degree, or 2 theta p is equal to 226.40 degree, implying 113.20 degree. So we know that theta x1 is equal to theta x sigma x1 is equal to sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta plus tau xy sin 2 theta. So now putting theta p is equal to 46.40 degree, we get sigma x is minus 7,000 plus 4,000 cos 46.40 plus minus 4,200 sin 46.40 is equal to minus 12,800 psi. Now for 2 theta p is equal to 126.4 degree, sigma x1 is equal to minus 1200 psi. Thus the principal stress and the corresponding principal angles are sigma 1 is equal to minus 1200 psi, for theta p1 is equal to 113.20 degrees, sigma 2 is equal to minus 12,800 psi, for theta p2 is equal to 23.20 degree. So we can see that theta p1 theta p2 differ by 90 degrees. So sigma 1 plus sigma 2 is equal to sigma x plus sigma y, and the sketch is shown here. And the maximum shear stress tau max is equal to sigma 1 minus sigma 2 by 2 is equal to minus 1200 plus 12,800 by 2 is equal to 5,800 psi. So the angle to, theta is to the plane having maximum positive shear stress, theta s1 is equal to theta p minus 40 degree, which is 113.20 minus 45 degree is equal to 68.2 degree. Maximum negative shear occurs at theta p1 plus 45 degree is equal to 5,000 minus 5,000 psi. So the normal stress acting on the plane of the maximum shear stress is sigma average is equal to sigma x plus sigma y by 2 is equal to minus 7,000 psi. Here is the diagram. Now 7.218. There is a surface of an airplane being subjected to plane stress with normal stress sigma x and sigma y and shear stress at an anti-clockwise angle theta is equal to 30 degree, theta is equal to 50 degree. So you have to determine stresses sigma y and tau xy. So given sigma x 100 MPa, sigma y and tau xy is to find out, and theta given 30 degree, theta given 50 degree. At theta 30 degree, sigma x1 35 MPa, at theta 50 degree, sigma x1 minus 10 MPa. So for sigma x1, sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta plus tau xy sin 2 theta, theta is equal to 30 degree, sigma x1 is equal to 35 MPa, hence 35 is equal to 100 MPa plus sigma y by 2 plus 100 by minus sigma y by 2 cos 60 degree plus tau xy sin 60 degree, implying sigma y plus 160 MPa plus 2 tau xy is equal to theta, which is equation 1. Now similarly for theta is equal to 50 degrees, sigma x1 is equal to minus 10 MPa, and putting that into equation we get 2.6 sigma y plus 1755 tau xy plus 46.6 is equal to, which is equation 2. Solving equation 1 and 2, we get sigma xy is equal to minus 63.57 MPa, tau xy is equal to minus 63.57 MPa, and sigma y is equal to 60.22 MPa. Now 7.317. There is given a surface on the point of a machine, sigma x minus 6500 psi, tau xy 21,000 psi. We have to determine the range of sigma y if the maximum shear stress is 2900 psi. So diagram, we have to determine the range of sigma y. So we know that tau max is equal to sigma x minus sigma y by 2 whole square plus tau xy whole square. So solving the equation, taking the square root over here, tau max square, so sigma x minus sigma y by 2 whole square plus tau xy square, tau max minus tau xy square, sigma x minus sigma square, and sigma x minus sigma by 2 is equal to root over tau max square minus tau xy square. Hence sigma y is equal to sigma x minus 2 whole into root over tau max square minus tau xy square. Now so putting the values, sigma y is equal to 6500 plus minus 2 2900 minus 100 square implying sigma y is equal to 2500 or 10500. So the range is 2500 to 10500. Now coming to 7.318, given at a point on the surface of a machine 1, the stresses acting on a face are sigma x 45 MPa, tau xy 30 MPa. So we have to again determine the available range of values for sigma y for tau max equal to 34 MPa. So we have to find sigma y. So for maximum shear stress, tau max is equal to again sigma x minus sigma y by 2 whole square plus tau square xy, implying tau max square is sigma x minus sigma y by 2 whole square plus tau square xy, then tau max square minus tau xy square equals sigma x plus sigma y by 2 whole square. Hence sigma y is equal to sigma x plus 2 root over tau square max plus tau xy square. And putting the values, we get sigma y is equal to 45 MPa plus minus 32 MPa. Hence sigma y ranges from 13 MPa to 77 MPa. Hence tau max is equal to 45 minus 13 by 2 whole square plus 30 square is equal to 34 MPa. Verification is done. So here is the graph: 30 MPa, 34 MPa, this is 77 MPa, and this is the value of tau max. Now coming to second problem, 7.319, given there is an element in plane stress subjected to stresses sigma x is equal to 6500 psi, tau xy is equal to 2800 psi. So one of the principal stresses is 7300 psi. So we have to determine stress sigma y and other principal stress and orientation of principal planes. So as sigma y is less than the given principal stress, the given one is a larger principal, hence sigma 1 is 7300 psi. So 300 is equal to 6500 plus sigma y by 2 plus sigma 500 minus sigma y by 2 whole square plus minus 2800 whole square. And on solving, we get sigma y is equal to minus 2500 psi. Now coming to principal stresses, so we have to find first the angles. Tan 2 theta p is equal to 2 tau xy by sigma x minus sigma y, implying theta p1 is equal to half tan inverse 2 tau xy by sigma x minus sigma y, and theta p1 is equal to half tan inverse, same formula. So theta p1 is equal to minus 15.95 degree, theta p2 90 plus theta p1 74.5 degree. So sigma 1 is equal to sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta p1 plus tau xy sin 2 theta p1 is equal to 6500 minus 1500 by 2 plus 6500 plus 1500 by 2 cos 31.9 degree, using theta p1 minus sigma 31.9 degree, which gives us 7300 psi. And now sigma 2, putting the value 74.5 degree, we get minus 3300 psi. So for theta p1, sigma 1 is 7300 psi. For theta p2 74.05 degree, sigma 2 is equal to minus 3300 psi. Thank you.